Okay, the derivative of a function f of x is f prime of x is equal to x times x minus 1 times x plus 2. Find the intervals of increase and decrease of f of x. So in this case, we want to first figure out critical points. Now the derivative function f prime of x here is equal to x, just get rid of the bracket here, but x times x minus 1 times x plus 2. And to find the critical numbers or the critical points, okay, if we find critical numbers of x, right, I'm going to let f prime of x equal 0. Okay, once I let that equal 0, then we can see that x is equal to 0, 1, and negative 2. Okay, so those are our critical numbers. And after we find the critical numbers, what we want to do is create some intervals. So a really quick way of doing this is I'm just going to create a table, a line, right? So this integer line or this number line is going to help us to figure out the interval. So in this case, here's 0, here's 1, here's negative 2, this is negative infinity and positive infinity. Okay, so because you want to find intervals of increase and decrease, these are points that will allow the function to equal 0. We don't want to consider when the function equals 0 because that indicates maximum and minimum points. So we can recall that at a maximum point or a minimum point, say the graphs look like this, at this point, right, the slope of the tangent is equal to 0, and at the minimum point, the slope of the tangent is also equal to 0. Okay, so we don't really want to consider those points where the slope of the tangent or the derivative function is equal to 0. In this case, what we want to do is we want to figure out intervals between values where we'd have an interval of increase and decrease. So this interval here is between negative infinity and negative 2, right here, right? This interval here is between negative 2 and 0. This interval here is between 0 and 1. And this interval out here is 1 and positive infinity. Okay, so we technically have a total of 4 intervals. Okay, so technically what you will see is that if you have 3 critical numbers, then you should have 4 intervals. You should usually have one more critical number than, sorry, you should have one more interval than critical number, right? So what you want to do next is you want to figure out which of these intervals constitutes an increase or interval of increase and which intervals constitutes an interval of decrease. Well, we understand that an interval of increase will occur when the first derivative function f prime of x is greater than 0, right? An interval of decrease will occur when the first derivative function is less than 0. Okay, so in order to do this, I'm just going to kind of I'm just going to organize everything in a table to kind of demonstrate this stuff. Okay, I'm going to put the intervals on top, so we have negative infinity and negative 2. We have negative 2 and 0, we have 0 and 1, and we also have 1 and positive infinity. Okay, and then I'm going to put the factors of my derivative function. And I'm going to, for my last row, I'm going to call this f prime of x. So each factor here, you have x minus 1, you have x plus 2, and these are just some values x will belong to in those intervals. Okay. So what we want to do is we want to find intervals of increase and decrease. Well, between the interval of negative infinity and negative 2, I'm going to pick a value. Let's say x is equal to negative 3. So in this case, x, because it's negative 3, it's negative, right? Because in this factor we have x minus 1, negative 3 minus 1 is negative 4, which is negative. And then negative 3 plus 2 is going to be negative 1, which is negative. And then if you multiply the negative values of each factor together, f prime of x here is going to be negative. So if f prime of x is negative, then we have a negatively sloping line, right? So that this basically would constitute an interval of decrease. Okay, so that's an interval of decrease. At negative 2 here and 0, x is equal to negative 1. In this case, you have negative 1 minus 1 is negative 2, that's negative. Negative 1 plus 2 is positive. Then you have two negatives, which is a positive plus times a positive, going to give us a positive. This actually gives us an interval of increase. Okay, so I'm showing this using a positively sloping line. For an interval of decrease, I use a negatively sloping line. Now you can notice here that we should have a maximum at -2 because we do have a critical point there. Sorry, not a maximum, but maximum or minimum at -2. So there's some kind of extrema there. Now we want to figure out what type of extrema you'd expect. You can actually determine this by looking at the change between an interval of increase to an interval of decrease, or vice versa. For instance, we have an interval of decrease here, then it switches to an interval of increase, and because of that we should have a minimum point. So we should have the minimum point at x is equal to -2. Does that make sense? Now between 0 and 1, let's test some values for this. I'm going to pick the value x is equal to 0.5. So let's do 1/2. Okay. When x is equal to 0.5, this is positive because x is 0.5. 0.5 minus 1, that's -0.5. 0.5 plus 2, positive, is 2.5. And then together, collectively, this is going to be a positive times a negative times a positive. It's going to give you a negative. And we're going to have a negatively sloping line like that. Okay. Now you can see that from the -2 to 0 interval, we had an upward sloping line, or an interval of increase, and now we're switching it to an interval of decrease. So you can notice here that we should have some kind of extrema here, a maximum or minimum, and because you're going from interval of increase to interval of decrease, this is actually going to be a maximum point. So there should be some kind of maximum point. There should be a maximum point at x is equal to 0. Okay, so we considered this guy. So this is a maximum. We said this is a minimum. Okay, now between the next interval, we have 1 and positive infinity. I'm going to pick a value. So let's pick, let's say x is equal to 2. Okay, so when x is 2, this is positive. 2 minus 1, positive. 2 plus 2, positive. And collectively, the three positives will give you a positive. F prime of x is going to be greater than 0, so we're going to have an upward sloping line. We also know that there should be some kind of 0, right, at 1. So x is equal to 1 is a 0. And in this scenario, if you take a look at the slopes, you go from interval of decrease to interval of increase. Okay, so this point here should be a minimum. So this actually would represent a minimum point. So this is a minimum. So we have 2 minimums and 1 maximum, because if you look at the degree of this function, because there's an x here at times x, you should see an x cubed term, right? So we can recall from our previous units of functions that if you have an odd degree polynomial, we won't have any absolute maximum or minimums. There is no absolute max or minimum points, but there will be local maximum and minimum. So these are actually local maximum and minimum points. Okay. Now in this case, we just wanted to find intervals of increase and decrease, which we can kind of see here, right? So, but I thought I'd just kind of extend this discussion to further look at maximum and minimum points, which we will continue to explore later on. So these are your intervals of increase and decrease, right? So the interval of increase here, we can see that we have x can belong to -2 and 0, union 1 and positive infinity, and an interval of decrease here, x belongs to negative infinity and -2, union 0 and 1. Okay.